So in this case I have this kind of shape. Okay, so first of all I'm going to define my part and the blank, and my blank is a bounding block. See, this is the bounding block. So I'm going to use this curve point drive method to cut this shape, and the tool I have already defined. The tool is as per the shape. So click this, and my drive is this curve drive, and the tool is ball mill, or we can use bull nose radius tool. Okay, and click it, and my method is this rough, and select this curve. Okay, and from the geometry I want to cut this shape. This is my area to be cut, and if I'm going to generate this toolpath is generate, and stock I want to keep this 0.5, generate it again. Okay, and now I want to define multi depth. So depth is 6, and increment, suppose I need 0.5 as an increment. Generate this again, and let's see the. Okay, because of tool and the stock, this is the result. Okay, optimize path, extend to the boundary, generate. If it is not up to the boundary, that time we can use this one. Okay, and now click OK, and now I want to pattern it. So number of instances are 10. So how to copy this? Right click here, and from the object we have the transform, and I want to translate this toolpath from this point to this. Okay, and the instance are 10, so input 9 because 1 is already there. So 9 will copy here, and OK. So first is this, and second is this, third. And if I want to check all this, select all this and verify this toolpath. Click. Okay, so this is the roughing operation. With the help of this we can use this same method, curve drive method, in 4 axis and 5 axis also, but here it is for the 3 axis.